Good morning and warm greetings, dear friends and students. Today I am going to deliver a lecture on indeterminate beams and indeterminate structures. So, what is called as indeterminate beam? The beam which consists of the number of unknowns, like the reactions. For example, in the case of fixed beam, we are having vertical, horizontal, and a moment, resting moment at one fixed support and another fixed support, again vertical, horizontal, and moment of resistance. So that means, 3 plus 3, that is 6 unknown reaction or constants will be there. But here only 3 equilibrium equations is available. That is sigma fx is equal to 0, sigma fi is equal to 0, and sigma m is equal to 0. That is, sigma fx is nothing but the algebraic summation of all the horizontal forces are equal to 0, and sigma fi, it is nothing but the summation of all the vertical forces is equal to 0, and the moment equilibrium equation, that is at any point, right, we are finding the moment due to the external internal loads or the sulfide is equal to 0. So only 3 equilibrium equations are available. For example, here 3 plus 3 is 6 unknown reaction in the case of a fixed beam. So number of unknown is 6 minus the number of available equilibrium is 3, that is 3 unknown constant cannot be determined directly. So that means it is an indeterminate beam. So if the number of unknown reactions or the constants are greater than the equilibrium equation, then the beam or the structure is called as the indeterminate beam or indeterminate structures. So another example, you take a propped cantilever beam. A cantilever beam, you are attaching the support at the free end, then it will act as a indeterminate beams, because at the fixed end 3 unknown and 1 or the horizontal reaction or vertical reaction if it is inclined load. So another 2 unknowns, so 3 plus 2, that is 5, only 3 equilibrium equation. So 5 minus 3, that is equal to 2. 2 unknown reaction or consign cannot be determined directly, then it is called as a indeterminate beam. So propped cantilever is an indeterminate beam. Then what are the other examples? Continuous beam, either 2-span continuous beam or 3-span continuous beam, because the number of unknown reaction or the constant is greater than the equilibrium equation. Again, it is coming under the indeterminate beams. Then if your continuous beam is having one end is fixed and having a 2-span, right? So another reaction at the support end. So 3 plus 1 plus 1, that is 5 again. So 5 minus 3 is equal to 2. 2 unknown reaction cannot be determined directly. So this fixed continuous beam is indeterminate beam. So in the case of frame structure, for example, if you take a portal frame, so which is having a 2-story building, which is having the 2 column, which is are fixed at the bottom end. So there are 3 plus 3, 6 unknowns, but the equilibrium equations is available is only 3. So 3 unknown reaction or constant cannot be determined directly. So you have to use the boundary conditions. What are the boundary conditions to go for the extra unknown reaction or constraint that can be determined? That is called as the boundary conditions. For example, at the fixed end, the slope and deflections are 0. In the case of portal frame, at one column end and another column end, again the slope and also the deflection both are 0 because of a fixed end. So here you have 4 boundary conditions: deflection equal to 0 and slope equal to 0 at the 2 column ends of a portal frame. So by using the boundary conditions, you can find the extra constraints or extra unknown condition can be determined. So that is called as the portal frame. So if the portal frame is having a fixed at one end and another one is a hinged end, means So 3 plus 3, 5. Equilibrium equation is available is 3 only. So 5 minus 3, that is equal to 2. So in that case, these two unknown constraints can be determined using the boundary condition, that is at the fixed end both slope and deflection are 0. To boundary condition at the hinged end, you know that the deflection is 0 unless otherwise if the column is settling the differential settlement. Okay, another, right, deflection are equal to 0. So three unknown conditions can be determined by using the boundary condition of these three. So then it is called as right, indeterminate structures. So in the previous videos before a month back, we are given the example for the determinate structures or determinate beams are given the example, but in the today's video we are given the clear idea and the demonstration of the indeterminate beams and the indeterminate portal frames. So this is an example. Thank you very much for patient listening. God bless. வாழ்க வையகம், வாழ்க வளமுடன்.